Hi there. For this assignment, I chose to create an inquiry-based assessment, in particular for a high school earth and environmental science class. So first off, I picked an inquiry-based project for several reasons. The first of which is that I believe that the inquiry-based model of learning really mimics the scientific process by asking students to process the knowledge that they're gaining, process their own observations about the world, and then use that to pose questions and get curious about things. And with that curiosity, the instructor can then help students to do research, design experiments, and find their own answers. And so mimicking the scientific process in that way also helps inquiry-based learning align really well with the next generation science standards, which I find have a lot of great detail and they're very skill-oriented, which is an awesome way to approach high school science. And finally, inquiry-based learning has been shown to be very effective not only at increasing student knowledge, but increasing their ownership and autonomy in the learning process. Really puts students in the driver's seat. So a little bit of context for this project. This would accompany the unit on how humans influence our water systems. And so this directly follows a unit on the structure and processes of the hydrosphere, like the water cycle that you might remember from the 3rd grade. And so previous units in this class have already touched on a lot of topics related to water, such as agriculture, mining, deforestation, energy production, pollution, erosion, all sorts of different things that we've kind of tangentially talked about water, but this unit is going to explicitly tie everything back to water quality, water pollution. So for this project, I'm asking students to identify some issue related to water quality that they feel an interest in, and then work to propose a potential solution to that problem. And for the final product, I'd like it to be very free form. I will go over some of the requirements that I have, but the product can take a lot of forms, such as students could choose a presentation, they could create a video that they post to social media, they could do some sort of writing as long as it has a real-world application, such as a letter to the editor or a magazine article. They can organize an event like a river cleanup, a trash pickup, or some sort of workshop. Or it can be a more artistic creation, such as a skit or a series of flyers, or really anything. It's pretty open-ended for students to choose, but I'll give them some examples and options in case they're not sure what direction they want to go in. And so I wanted to mention briefly the standards that this project should align with. In particular, there are 2 standards from the North Carolina set that I think this project aligns with. The first is to evaluate human behaviors in terms of how likely they are to ensure the ability to live sustainably on Earth. And so this is actually a standard for the last unit of the school year, but I think this project kind of gets a head start on that by asking students to evaluate human activity and how we can improve water quality through our actions. And the second is to evaluate how humans use water. And so this is a big purpose of the unit, and so this project will be evaluating all about how human activity impacts water. I also wanted to include a couple of the next generation science standards. Even though North Carolina hasn't adopted these yet, I find them to be very skill-oriented and more detailed than the North Carolina course of study. So I wanted to go ahead and include 2 that kind of feed into this project. And so the first one involves evaluating or refining a solution that reduces the impacts of human activity on natural systems. And the second is to evaluate design solutions for developing or utilizing resources based on cost-benefit ratios. And so I'm asking students to do parts of both of these skills for this project, and there will definitely be other projects throughout the semester where hopefully they will more explicitly address these 2 standards. There are two major requirements for this project. I haven't included the full rubric, but just to kind of give you an overview. The first requirement is that they must address a real-world problem and be able to quantify the current extent of that problem. So for example, it might be what types of pollutants are in the waterways in their county, or different waterborne illnesses that the fish are experiencing due to non-native species present in the waterways. So there's all sorts of different directions students could take this. And the skill that that relates to, like I said, the next generation science standards have a lot of really great skill language, and so I wanted to tie that in as well. Some of the skills that they need to display are to select and interpret relevant data. That's kind of the whole point of this requirement. And a second skill that they'll have to use is to use units as a way to understand a problem. So they can't just tell me that there's, 10 parts per million of lead in the water or something. They have to say why that 10 parts per million is a problem, what it should be. They have to get more specific with how they use units to evaluate information. The second big requirement of this project is that they must include a cost-benefit analysis of their proposed solution, including social, cultural, and environmental impacts of that solution. So some of the skills that this relates to are the ability to reason abstractly and quantitatively, to make decisions based off of evidence. And supporting evidence in support of a claim is just a huge skill across the sciences. They have to be able to make good arguments and evaluate others' arguments. And so this project is hopefully getting them ready for some bigger instances of that later in the class. So just a couple notes on how I think this project will be implemented. Typically this is a 2-week unit on the human influences on water. And so I want to start early. I want to introduce this assignment on day 1 and provide some time for students to brainstorm on what direction they might want to go in based on the implications we've already talked about for water quality. And I might even break students up into groups based on different themes. On the third day of this unit, I want students to submit to me just a preliminary proposal about what they're hoping to do. And then I want to provide them with some time with peers, again, maybe grouped based on different general categories or topics, and allow them to get some time together to compare ideas, to maybe research together, and overall just to continue brainstorming how they want to go about this project. On around day 7, I want to do individual check-ins with each student to make sure that they're on track, that they have a solid idea, and just to better support whatever they're needing at this phase in the project development. And then outside of that individual check-in time, I want to provide them with some time to talk to their peers as well, maybe swap tips and tricks. And then finally, on the 10th day, that would be the end of the unit. I want to set that aside for presentations for students to talk about their projects. They might not be able to all do a river cleanup that day, but I want them to at least be able to show the class what their plans are for the river cleanup or pictures of how it went. Just have some time to really highlight each student's achievement. And this would be the major grade for this unit. And so I just wanted to connect this again to inquiry-based learning because I'm hoping that this is an example of an inquiry-based assessment. So inquiry-based learning needs to be student-centered, and the instructor is there as a guide to make sure that students don't get lost along the way. But it really is supposed to focus on student interests and helping them to discover their passions and their own motivations. Another hallmark of inquiry-based learning is that students get to ask their own questions and then find that information for themselves. So the teacher is not the one providing all the information, they're just helping students figure out ways that they can get that from other sources. And so in this project, students are asking their own questions, they're evaluating options, they're proposing solutions, and then they're getting to choose how they want to present that information. So again, very student-driven. Inquiry-based learning also tends to have kind of this focus on skills over knowledge that I really love. That's why I love the Next Generation Science Standards. And so this project is really based on how well can they identify and propose solutions, how well can they create an effective argument, how well can they address that problem, more so than how much do they know about this particular issue, because the whole point is for them to learn about it while they go through this project. And then finally, inquiry-based learning attempts to provide a broader context and real-world applications for knowledge, as well as skills. So in this project, maybe not every single one of them will come up with something that has a real-world application, but I'm hoping that I will be able to give them enough guidance that they can produce something that feels authentic, something that has some connection to their community, to their lives, something that gives them that broader context that makes learning meaningful. And here are some of the references that I cited. I hope you have enjoyed, and I look forward to seeing what everyone else is designing.